This video is going to look at the combination of functions, and basically all that is looking at if you're given multiple functions, like here we have f of x and g of x. We're going to look at how do we add the two functions together, how do we subtract, how do we multiply, and how do we divide these two functions. So if you're given two functions as we are here, if we want to find f plus g of x, then that simply means that we're looking for function f of x plus g of x. So all we're going to do is add the two functions together. So we're going to take x squared plus 2 and add that to x plus 1. Now if you notice, I will put these in parentheses, although for this example we really didn't need the parentheses, so we would end up with x squared plus 2 plus x plus 1, and then we simply combine our like terms. So we have x squared plus x, 2 plus 1 is 3. So there we have f plus g of x is equal to x squared plus x plus 3. So that's all we're doing, is adding the two functions together. And then you probably would guess here, then we would look at how do we subtract the two functions, f minus g of x. And that simply means we're looking at f of x. Another way to write this is f of x minus g of x. And this is where your parentheses are important. We would have x squared plus 2 minus x plus 1. And you'll notice here the reason the parentheses are important is because now when we go to simplify this, we actually need to distribute the negative sign here. So we're going to distribute this, and we're going to end up with a negative x and a negative 1. So then when we combine our like terms, we would have x squared minus x, and then 2 minus 1 is equal to a positive 1. So we end up with f minus g of x. Okay, the next operation is we want to look for f times g, which another way to write that simply means we're looking at f of x multiplied by g of x. Now be careful with this notation here. I'll put a little star by this just to remind you that this is multiplying. A little bit later we're going to look at a slightly different notation. It looks very similar, but it means something very different. So if there's no symbol here, this means f times g of x. So if we're going to multiply the two functions together, that means we're going to take x squared plus 2 and we're going to multiply that by x plus 1. Now, of course, here we're multiplying two binomials, so that means you would use your FOIL, or you could just think of distributing twice. We're going to distribute the x squared to x and 1, and then you're going to distribute the 2 to the x and 1. So x squared times x is x cubed. X squared times 1 is 1x squared. And now we're going to distribute the 2. 2 times x is 2x, and 2 times 1 is 2. And for this example, we have 4 different terms, so there's no like terms that we can combine, so that is our answer for f times g of x. And the last one we're going to look at is f divided by g of x, and we could certainly think of that as f of x simply divided by g of x. And our f of x was x squared plus 2. So we're going to take function f divided by function g, which is x plus 1. And really at this point, there's not a whole lot we can do with this, so that would be our answer. Simply x squared plus 2 over x plus 1. Now we can look at some information here as far as we go back. We could think about looking at the domain. If we wanted to look at the domain of function f up here, x squared plus 2, well, hopefully you realize we can square any number and add 2 to it, and x squared plus 2 is a polynomial function, so that means the domain would simply be all real numbers. Now, what about the domain for function g, x plus 1? Well, x plus 1 is just going to be simply a straight line. You go back to those parent functions. We know x plus 1 is going to be a straight line. y-intercept at 1, slope 1x, so the slope is 1. And again, that would simply be all real numbers. Now, what if we look at the domain of each one of these? If we add the two functions, notice we get x squared plus x plus 3. Again, that's a polynomial, so your domain is all real numbers. F minus g of x, same thing. X squared minus x plus 1, a nice polynomial function. Domain is all real numbers. Same thing for f times g. Now, what happens, though, when we look at f divided by g? When we look at this one, what is the domain here? Well, because we're dividing, we have this x plus 1 on the bottom. Well, if x plus 1 is equal to 0, then that means x is equal to negative 1. So your domain would be all real numbers except x does not equal a negative 1. Because if x is a negative 1, we get 0 in the denominator. So what I want you to be aware of, just because the two functions up here, f and g, the domain for f and g are all real numbers, if we look at dividing those or some other combination, your domain may not be all real numbers. You may have to have some numbers excluded, as we do here, where x cannot be equal to a negative 1 because we have division by 0. All right, so that's pretty much it for the combination of functions. I'll go through a few more examples here. If we have the following function, say f of x equals x squared plus 1, and g of x is equal to, let's say, x minus 4. And we want to find f plus g of 1. Now, there's a couple ways we can go about this. Notice here this is not an x. We want to find f plus g of 1. There's two ways to think of this problem. Well, the first step is we could find f plus g of x. Now, we could do that first. If we do that, that means we're going to have x squared plus 1 plus x minus 4. Now again, here we would have these in parentheses, but because we're adding, they're not really needed, so I'm going to leave them out. And we would end up with x squared plus x, and 1 minus 4, we would have a negative 3. Now this here is f plus g of x. This is our function. Well, up here, we want to find f plus g of 1. Well, if this is the function here, f plus g of x, then all we have to do now is plug 1 in for x. So if I'm looking for f plus g, if we're looking for f plus g of 1, then we're simply going to plug 1 in, and we would get 1 squared plus 1 minus 3. And we're going to get 1 plus 1 is 2, 2 minus 3, so we end up with an answer of negative 1. Now, an alternate way to solve this, if you have f plus g of 1, and maybe a little bit easier way is, this really says you're looking for f of 1 plus g of 1. So we could certainly just take and plug the 1 in here, and we would end up with 1 squared plus 1, and do the same thing for g of 1, plug the 1 in for the x here, and we would get plus 1 minus 4, and we would have 1 plus 1 is 2, plus 1 is 3, 3 minus 4 equals a negative 1, and you'll notice we end up with the same answer. So there's two ways you can do this. If you're looking for f plus g of a number, then you could simply find the f plus g of x. You could find the actual function and then plug the number in as we did here for 1. Or if you're looking for f plus g of 1, you could simply plug 1 into function f, plug 1 into function g, and then add the two together. Okay, either way is perfectly fine. All right, let's try another example. And we're going to use the same function here. Let's say that we have still f of x equals x squared plus 1, g of x equals x minus 4, and we want to find this time f plus g of t minus 2. So once again here, you you got the two options we did above. Now notice here, we're not just plugging in a number such as 1 or 4, we're plugging in t minus 2. Now what I would suggest is we could still, once again, because we already know what f plus g of x is, right? We found that above. Up here, f plus g of x was x squared plus x minus 3, because we can use this because we're looking at the same function f and g. So I'm just going to look at x squared plus x minus 3, x squared plus x minus 3. There's no need to redo the work we've already done. So now, if we're looking for f plus g of t minus 2, all we're going to do is plug t minus 2 in everywhere there's an x. So we would have x squared, so that becomes t minus 2 squared, plus x, so that would be t minus 2. And then we have the minus 3. And then from here, all we have to do is simplify. Now, t minus 2 squared, again, that means we're going to write that out twice and FOIL it, or the shortcut says square of t, so that's t squared. Multiply the negative 2 and t, that's a negative 2t, and we're going to double that, so that becomes a negative 4t, and square the negative 2, which is a positive 4. And again, if you can't do it this way, just simply write this down as t minus 2 times t minus 2. And then we have plus our t minus 2 minus 3. And we can go back and combine our like terms. We have the t squared, negative 4t, and t would be a negative 3t. And then 4 minus 2 is negative, let's see, 4 minus 2 is 2, 2 minus 3 is a negative 1. So there we have t squared minus 3t minus 1. So we're still doing the same process. Basically here, all we're doing is substituting in for x. In this case, we were adding the function. And it doesn't really matter the operation here. This could have been f times g, then we would have simply multiplied function f and g, or if we were dividing, you'd simply divide function f and g. All right, so let's look at another one here. And again, for convenience, we'll use the same function for f and g. And let's say that we want to find fg of 5 plus f of 4. Well, this says f times g of 5, so we need to first find function f times function g, and we want to plug 5 into it. So I'm going to go ahead and plug the 5 in. So if we do that, we would have, in place of x squared, we would have 5 squared plus 1. So there's your f of 5. And we want to multiply that by g of 5. Well, if we plug 5 in here, you're going to get 5 minus 4. Okay, so that's the first part. Then we have plus f of 4. So let's just go to function f and plug in a 4. So that would simply be 4 squared plus 1. And then all you have to do is simplify this. So we would have 25 plus 1 is 26. 5 minus 4 is 1. And then 16 plus 1 is 17. And then 26 plus 17 equals 43. So there you have it for your combination of functions. Realize here that all we're doing is adding the functions together, subtracting, multiplying, or dividing.